charge on the hydrogen end. Dipole moment. The polarity of a molecule is often described by its dipole moment, which is the product of the magnitude of the charge and the distance between the charges. The dipole moment of a molecule is a vector quantity, with the direction of the vector pointing towards the partial negative end of the molecule. Properties of polar molecules. The polarity of a molecule plays a critical role in determining its physical and chemical properties. Polar molecules have higher boiling points and melting points compared to nonpolar molecules, because they have stronger intermolecular forces. Polar molecules are also more soluble in polar solvents and less soluble in nonpolar solvents. This is because polar molecules interact more strongly with other polar molecules than with nonpolar molecules. Polar molecules also have higher surface tensions due to the stronger intermolecular forces between the molecules. Applications of polarity in chemistry. The concept of polarity is important in many applications of chemistry. For example, it is used in the design of solvents, separation techniques, and in understanding the properties of biological molecules such as DNA and proteins. Polarity is also important in industrial processes, such as the production of synthetic fibers and the development of new materials. Types of polar covalent bonds. Polar covalent bonds can be categorized into two types: pure polar covalent bonds and coordinate covalent bonds. Pure polar covalent bonds occur when two different atoms share a pair of electrons unequally, leading to partial charges on the atoms. Coordinate covalent bonds occur when one atom donates both electrons to the bond, resulting in a partial negative charge on the donor atom and a partial positive charge on the acceptor atom. Electronegativity and polarity. The degree of polarity of a molecule is determined by the difference in electronegativity between the atoms in the bond. Electronegativity is the measure of an atom's ability to attract electrons towards itself. The higher the electronegativity of an atom, the more it attracts electrons towards itself, resulting in a partial negative charge. When the electronegativity difference between two atoms is significant, the bond is polar. Polarity and intermolecular forces. Polarity plays a crucial role in determining the intermolecular forces between molecules. Polar molecules experience stronger intermolecular forces than nonpolar molecules. This is because the partial charges on polar molecules attract other polar molecules through electrostatic interactions. This leads to higher boiling and melting points for polar molecules compared to nonpolar molecules. Applications of polar covalent bonds. Polar covalent bonds have numerous applications in chemistry and materials science. For example, they are used in the design of new materials such as polymers and fibers.